It should be going live. Okay, it says an error occurred on LinkedIn. So we're going to start again. Okay, I think we are live now. All right. If I just look at my own post, I guess that's the best way I check if I'm going live. But you guys can see it as well, I guess, if you have. Yes. Oh, not yet. I'm not sure. Can you guys see Deepanjan? Can you see if you're live? This is just a quick check. Probably you'll have to see on my LinkedIn handle.
Sure. Yep.
We are live? Yeah, we are. Awesome. I can see it on my phone as well. Cool. Okay, guys. Thank you, everybody. You know, we've been kind of having this drum roll, and Andreas has probably seen his mention on LinkedIn more often than on Twitter, which is where Andreas lives. As I always say, most of the real experts in deep learning and machine learning, no disrespect to LinkedIn folks, actually reside on Reddit, probably Discord, GitHub, or Twitter. And there's a reason for that, because there's a lot of interaction that happens in machine learning space, where if there's new product or a new research paper being published, Twitter seems to be a great handle where people tend to watch each other. Sure enough, I mean, LinkedIn is more like a professional space where people with different backgrounds kind of come together. And we are super excited to have Andreas with us, Andreas Madsen from Denmark, and Deepanjan Sarkar, who I asked yesterday to also participate as a guest speaker. He's a good friend of mine, a wonderful gentleman. I've sort of been seeing him for the last 3 years. So the theme is going to be me introducing these two gentlemen, as we've just done, give you a little bit of an overview of what we actually are going to do in this talk, including what we believe in, so you get a bit of an idea on why do we bring folks like Andreas, Deepanjan, and other people. In the coming months, we'll be having guys who created CNN Explainer, GAN Labs, and a bunch of really exciting applications. And it's going to be like 5 minutes, and then I will sort of let Andreas introduce himself in detail and take you into this journey. So let me just kind of give you a bit of a perspective by sharing what we mean when we talk about research. And actually, what I wanted to do was to show you a Chrome tab, and I hope you guys can see this. So basically, what we are, so from a Deep Kappa's perspective, so I'm CEO and co-founder of Deep Kappa. Real AI is another company, and Live AI, which is this sort of a platform in which we bring education and workshops to you. People normally ask me this question, and I'm sure within Andreas's community in researching, and Deepanjan, who's also been a developer side and a software engineering side, is, well, how do I kind of participate in becoming an impactful a professional or researcher in AI, or which is machine learning or deep learning? So my understanding as to what has worked for us successfully is, so research is a huge domain. You can do research in a variety of areas and use really variety of tools. And similarly, sort of engineering as well. Engineering has been there for a long time, software development as well. But to make impact, what we always say, at least what I say, is that if you are sort of navigating into this domain and you're essentially kind of researching at the peripheries of your own interesting research, for all you know, you're doing some wonderful sort of yeast or biomedical engineering, some other sort of really interesting study. But if it has not much affinity to machine learning or deep learning, it becomes very difficult for you to contribute and to participate in that field. As you come closer to these domains, so if you struggle, if you're here, you're in the yellow spot. And what we believe is, what we see is when you are kind of converging towards the center of research, engineering, and software development, that's where you start making a lot of difference. The reason why I'm kind of explaining this is because people ask me a lot of times when we are hiring or recruiting researchers or engineers or developers is that, well, I have a lot of engineering background, I have developed in Java, and then we keep asking questions. In which perspective have you worked with machine learning or deep learning applications? And if that answer is yes, then you're definitely closer into this domain. If the answer is no, then you're struggling around here. So that becomes a bit of a challenge. And so if you are in engineering but doing things that actually don't have much to do with machine learning or deep learning, my advice is to try to move the ball towards the center, meaning your learning curve, and that makes a huge difference. And similarly, I have questions where we are hiring right now for software development because we're developing tools and interesting tools. And I'm sure you've seen things like what guys are developing right now, the backbone of GPT-3, all kinds of intuitive sort of, speak into your computer and it generates code, or just type something, it creates software code, HTML code, CSS, and all that work for you. It only happens when you are trying to understand how the models were built, whether GPT or BERT or all the other models, and essentially applying and doing software development. But if you say, well, I am a Golang developer, I have built some nice applications, but do not have affinity to, let's say, the center, which is machine learning here, then you will struggle. So I think the whole purpose of these talks is to bring people like Andreas and a bunch of other folks in the industry, which we will be doing in the next couple of months, is how do we bring these three disciplines together, and how do we make research, engineering, and software development a sort of an effort where people understanding each other from a machine learning perspective. So that was a little bit of a sort of an introduction. Going a little bit deeper into recurrent neural network, as you may know, is a deep learning sort of big sort of cousin in the NLP field, which is much wider space, actually, if you ask me. And recurrent neural network have been used successfully to also generate, actually, like a precursor to what GPT or BERT are doing. I've used recurrent neural network in 3-4 years ago to generate sort of new textbooks and stuff like that, using bidirectional recurrent neural network. But for folks who are not familiar with NLP at large, recurrent neural network is a deep learning sort of family member in this whole NLP domain. And I think that is a field where Andreas is also going to be talking about. And without much ado, I want to now sort of sit back and enjoy this wonderful workshop Andreas is going to give. It's going to be a learning experience for me because I haven't spoken to Andreas before. We've interacted a lot in the past, and I'm super excited to hear how did sort of, Andreas come up with all these wonderful sort of ideas. He's gone to publish on ICLR and also NeurIPS, formerly NIPS. He's got a Spotlight Award for one of his works, and he and his co-authors have also gone to improve the work of DeepMind's. I think it was Nalu paper. So those are fascinating things. But like I said, let's hear from Andreas. And after Andreas is going to spend the next half hour, I think, or maybe more, depending on how much time he has, and if it's super exciting. And we're going to introduce quickly Dipanjan Sarkar, and Dipanjan and Andreas can now, after this wonderful workshop, they can interact with you guys. I will interact with you guys also, and we are going to answer your questions. So all in all, I'm expecting another 45 to 50 minutes of this wonderful conversation. And I want to hand over the floor to Andreas. Andreas, very happy to have you here. We obviously want to know you as a person, who you are. If you can just introduce yourself and take over and please give us a nice workshop on your textual heat maps.
Thank you. Yes, so my name is Andreas, and I'm here to talk to you about textual heat maps. So I don't know if you can pull up my screen sharing.
Yeah,
there we go.
There you go.
And really what I want to do, like fundamentally with my research, is to make machine learning more socially responsible. And right now I'm very interested in sort of the dynamics between machine learning and, for example, our judicial system. which I think right now is really broken, and we will get to see that. Yeah, I can talk a bit more about me, but I think a good way to start is actually back in 2014 for me, because this is where my motivation for this really started. So I was at this conference here, and there was a bank presenting. This wasn't an academic conference. They were saying, well, we have developed this amazing machine learning model for predicting if our customer are able to pay back a loan. And of course, this being 2014 and a bank, you probably shouldn't trust anything, especially that it's amazing. But for sure, okay, it worked for them, and they were pretty happy about this. But they did mention that one small issue was that actually the customer-facing advisors, they didn't understand or trust the model, and sometimes they would go against it. The presenter just sort of left it there. There was just a small issue, and then later I went up to them and asked them about it, and they were just like, oh, well, we just did some visual discretization and told them to trust it. And I really thought, wow, they missed the point, because they have developed a model, and no matter if it's good or bad, their own bank advisors who are facing the customers and who have like master's degrees in economics, they don't understand it. They cannot explain it. And so when you're sitting there as a customer and asking for a loan, and like this person here with a financial degree just says, well, sorry, the computer says so. You cannot get a loan. I cannot tell you why. Like, that is a huge problem. And it's something that's going to affect us all. And now, of course, it's no longer 2014, and so we have things like GDPR. And I think for a lot of people, GDPR is, well, annoying pop-ups on the web, and also some protection of your data. But it actually goes much further than that, and also gives you some right in terms of how can companies such as a bank actually use data. And so in particular, there's a couple of paragraphs, but in particular, I found the Article 13, paragraph 2, to be quite interesting. So I will try and less legal speech here, but what it says is the controllers, in this case the bank, provides a data subject, which is a delightful legal term for you as a customer, with the information necessary to ensure fair and transparent processing. Right. And so that certainly means that they have to be fair, okay, and transparent, yes. But then in particular, they say here regarding the existence of automated decision making, then in at least those cases, we have to provide meaningful information about the logic involved. Right. And so they actually do have to explain the model. And I think we can all think of 100 cases where this doesn't happen. And just recently, I think last week, we had this one.
Oh, yeah, I saw this indeed.
Yeah.
I was like crazy, yeah.
So meet the secret algorithm that keep a student out of college, right? So this is just an algorithm that has no transparency and no explainability. That is actually secret, and I think it was employed in Germany. That is controlling people's life through their grade, right? And so we're in this case, well, we have the law, and obviously we have cases that doesn't necessarily follow the law. Certainly they are not providing the logic. But also there's the question of is it fair, right? And so, well, you would then maybe take this to the court, right? And then you would have to then explain the model retrospectively, right? The model was never designed to be explained, but you still have to explain it. This is sort of where the link between our judicial system and machine learning is just broken, because right now we cannot explain machine learning. it is like slicing up a human brain, looking at every single neuron and asking, what is your favorite color? Like, we cannot do it. And so really, I think this is a really key problem that I think is getting far too less attention in machine learning. Right, and so a bit more about me is, I'm an independent researcher, and what essentially means is I don't get paid for my research.
Oh man, then you should work with us. We pay our researchers.
And I work on interpretability. I would also like to say I work in visualization, although those that actually do research in visualization is something quite different. And in particular, I'm just interested in like how can we actually build trust around machine learning. And then I also work as a freelancer where I do mathematical models, machine learning, all sorts of things. I'm a lot less picky. This is how I earn my money. And last year I was like 3 months as a freelancer and 7 months as a researcher. Just to give you an idea about how I split my time. And really, I think it gives me a lot of insight into sort of the dynamics between the industry and the dynamics between research. I do want to say, like, this is not how I want to live my life. It's pretty stressful, but it's a solution right now. Right. And so what we'll talk about today is, this textual interpretability or textual heat maps. And for me, this started in 2018, where I read this paper here called Nested LSTM. And while the content of the paper is not particularly important, just to understand, there's this thing here called LSTM for understanding text, and this is some improvement they made on this, and they claim that this has what they call a better long-term memorization. And the way they visualize this, or the way they like show that it has better memorization, is they do this kind of visualization here, where they visualize what is the activation of a single hidden unit. And then they show, their version have higher activation than the base LSTM unit. And really, this is, in my honest opinion, bullshit. Like, you cannot make this kind of comparison, because a single hidden unit doesn't say anything about the whole network as a whole. And you can have a hidden unit that is only responsible for something that is short term. Right, but I thought this was a really interesting question, right? Like, so this doesn't work for saying something about memorization, but then how can we actually do that? And this is where my paper comes in and tries to answer this, visualizing memorization in RNNs. And I published this in Distill, and Distill is really a super nice journal that allows me as an author to develop these kind of interactive visualization. Really, what they've done is they say, well, what if PDFs and paper is not the way? What if we embrace the web platform? And we can create these visualizations then. So the first thought for me was, what they typically do in these kind of papers is that they use something called Chinese poetry generation or pen tree bank. And this is really problematic to get sort of intuition about, because it requires you as a reader to be very familiar with, for example, Chinese poetry, which most of us are not. They're nice from sort of a mathematical and linguistic point of view, but they're not very easy to interpret and have an intuition about. So I designed this data set here called autocomplete, which is essentially something you're all familiar with from the phone, where you type the characters and then it tries to finish the word by predicting the word. And there's sort of two components to this, right? So, for example, as it types parts now, it's a guessing that is part once you guess a few characters. But then we also have, for example, Africa here, right? Parts of North AF, and it understands it's a location. Immediately once A is typed, it doesn't suggest and as the most likely thing. It suggests America, because North America is very likely. And so this is sort of where the more long-term memorization comes in. Does it look at the previous words? And the short-term memorization is, does it look at the characters from the word itself? Right. And so then the way I wanted to frame this is really, what are the important parts of the input for making this prediction? Is it the characters from the word itself, or is it the previous words? And this is the only math I'll show today. The way I did this was I computed the gradients between the side output and the input. And really what this gives you is sort of a sensitivity measure. So you're saying, well, if I change this character here, how much is that going to affect the output? And this is called a connectivity score. Later I've learned in computer vision, this is actually something that is done. And we will talk about this. At the time I didn't know about that field. So I call it connectivity. They call it an importance measure. But yeah, really it's like, okay, if you change this character here, how is it going to affect output? And so this brings us sort of to the main slide, which is an interactive view here. So now I'm actually controlling the cursor and using interact. And what it does is that for each character, we are asking this question here: what were the important parts of the input for making the prediction? And so we can look, for example, at the first G here, and it suggests government, so context, the formal study of government. This somewhat makes sense, although it's not really what we want. And then as we continue to type in more and more characters, so now we type in gram, then it does understand that it should be grammar. Well, we can go on like this and type in our characters. And then once we get to the second occurrence of grammar is where it gets more interesting. So already here, we now see that the GRU model is actually able to now predict grammar as when it just had the G, right? And so this is because it has much more context, right? It's seeing everything that was typed previously from context to the second occurrence of the grammar here. But in particular, we see that it's highlighting the first occurrence of grammar. So it somehow has learned that if a word appears once, it's probably likely to appear again. While in the LSTM case here, we see that it doesn't really have the same kind of contextual understanding. Well, it does have contextual understanding, but it's much shorter, right? It only looks at the characters from the word itself. And so this visualization really highlights a difference between these two cases here. And so I want to be clear that I'm in no way suggesting that I think GRU is better long-term memorization than LSTM. I think this is very specific to this particular data set and these particular seeds of which these models were initialized, right? But when you do deploy a model, right, like the auto grader, you have a particular model, right? You're not looking at the architecture, you're looking at the actual model that was deployed. And so then this kind of comparisons do make sense. Right. And so I think the central point here when you create this kind of visualization is, I think intuition is developed from a feedback loop. And in particular, I think that interactive visualization provides a really good feedback loop, because like we were just going through it, right? You could probably come up with some of these conclusions yourself without really knowing anything. Just because when you're looking at the data, you're immediately asking yourself questions, consciously or subconsciously, and you're exploring to answer those. And having this kind of like fast interactive visualization really gives a very tight feedback loop, and I think that is central for the intuition. Right. And so now we get to the really important part, which is confirmation bias, because okay, we can develop this intuition through visualization, but there's one major issue, and that is our brain, really. So the problem with our brain is that we are susceptible to what is called confirmation bias, and this is really where we interpret or favor information in such a way that it confirms our own personal beliefs. So maybe we already somehow was thinking, well, words that have occurred before are likely to occur again, right? And maybe the sort of link that we saw doesn't necessarily generalize to everything. It's just what we concluded because we have these kind of biases and we have our own personal beliefs here. And so what is really central and really important, both as an engineer and as a researcher, is to transform these intuitions that we develop into quantifiable hypotheses, right? And so this is what I did. I asked them the question, okay, so if we just, for example, take one character from the word, how good is the model? Or if we take 10 characters from the word, how good is the model, right? And so if the model is really good, then if the model is really good with just one character, then it's because it understands the long-term context. And if it's really good for many characters, then it's because it understands the short-term context, just the characters from the word itself. And so we actually do see here that the GRU is better when there are few characters. It has higher accuracy, and so it is better as long-term memorization or long-term contextual understanding. But actually, interesting, the LSTM is better at when there are many characters. So this one is actually better at short-term memorization. So we cannot necessarily say that one model is better than the other. It's just these two particular instances have slightly different behavior, right? And so this both sort of validates the intuition that we develop, but we also sort of have to maybe understand that, well, maybe the differences is not that great, and also is not necessarily just that the LSTM is worse. It just has different things that it gets or looks at, prioritizes, really. Right. Yeah, so I promised you to talk about computer vision, and the reason why this is important is because a lot of this kind of research has actually already been done in computer vision, and it works out a bit differently. So what they have here is they have BERTs, or really images from ImageNet, and then they want to classify what it is. So this one is corn, this one is a Jungle bird. I have no idea what that is. Then they're essentially asking, well, what pixels from the image are important for making that prediction, right? And if you want to compare with what we saw earlier with the text, the model I implemented, or the method I implemented, is actually what's called the gradient method, which looks actually to be the worst of these. While there are other methods, such as the gradient times input, maybe the guided backprop, or integrated smooth gradients, like really a lot of them, they look better. And they highlight the birds or the subject better. And then we can look at this thing called the edge detector, right? And so what an edge detector is really just a super simple one-liner model that just detects edges. It doesn't actually have anything to do with the model that they trained. But it also highlights the bird. And so now we sort of have to ask the question, like, if we didn't know this was an edge detector, and I just gave you this as sort of a visualization, you might say, well, this actually looks like a pretty good way of visualizing what pixels are important. But we do know it's an edge detector. We do know it has nothing to do with the model. And so really we have to ask ourselves regarding all these other methods, how much do they actually have to do with the model, and how much do they just, through mathematical dynamics we don't fully understand, just become an edge detector. This is where this paper here by Sarah Huger comes in, and she asked this kind of question last year here. And what she's done is develop a benchmark for this kind of interpretability for images. And talk a bit about what it did, but first maybe we can, well, these graphs are not so great, but what they show is actually only 2 of these, I think, 14 methods they tested, and that have been published previously in big conferences. Only 2 of those were actually better than a random baseline. And so the way they did this is they essentially say, well, if the method says these pixels are important, then if we create a new data set where all the important pixels were removed and we train a new model, then that model should be a lot worse. And if it is a lot worse, then it's probably a good measure of importance. But if it's not worse than just removing random pixels, then it's not a good measure. And really what this show is, a lot of these methods are not better, only 2 of them. And those 2 are more or less identical. Right. And so we really have to ask ourselves, like, why were there so many papers published all claiming that this is a better way of measuring importance? And again, the answer is really confirmation bias. Because all these previous papers, they didn't have like proper benchmarks for measuring this. They were just doing the visualizations and just showing, well, the intuition, and this seems to look correct, but they were not really like showing quantitatively. And so it just goes to show again, like, even these really brilliant researchers are susceptible to confirmation bias, and it's been going on for like a lot of years. And now I think we also have to ask ourselves, like, is what I just demonstrated, is that also flawed, right? And maybe it is, maybe it's not. I think this is an important area of research, and I think there's really a lot of important differences between NLP, so text, and computer vision, so images. Particularly, for example, you can remove like 10% from an image and you might still be able to understand it, but removing 10% from a text is very different. Also, in images, we have actual signal noise from the camera sensor. In text, we don't. We like type it in, right? Also the pixels there, well, they're not continuous, but we can sort of like describe them as being between 0 and 1. In terms of, for example, the brightness of each color. While in text, you cannot really like say something between A and B. It's either the character A or it's the character B. And so this is really where I want to like encourage more research into the field of these kind of textual visualizations. And I want to do this by making these kind of interactive visualizations easier for researchers to produce. Because I've seen a lot of researchers, and to be frank, a lot of researchers are not that great at programming. And particularly if you ask them to make like a web application, like I just showed you before, they're going to think they'll die. So I made this Python module here, which is really just 3 lines of code you can put in Jupyter or Google Colab, which are popular research tools. And it's gonna give you this interactive visualization directly in the browser. And so you really just import the Python module, you set up some properties, and then you set the data. And what is important here is this is really just a plotting tool. So you are in control of what are the tokens, how do we represent text, how do we measure importance. And so I want to give you a very different example here where I use this tool. My cursor here just disappeared. Here it is. So this is BERT, which many researchers will be familiar with. And really what it can do is you can sort of mask a word. So for example, you can hide study, and you can ask it, please predict study. It can do a lot of other things, but this is sort of the very basics of it. So we can sort of go through each of these words here, and we can hide each word, and then we can ask it to predict it. And then we can again ask this question here, what were the most important inputs in making this prediction? And so again, we can look at grammar, for example, and we can now, so BERT is a bit different from before in that it sees the entire text, not just the text that came before. And so it can actually look at grammar, the sectional curves of grammar here. It can also look at language, for example, which really gives you some insight. And it actually suggests grammar immediately. And again, we can look at the second occurrence of grammar, and this one also suggests grammar. And here I'm then comparing two different models, BERT and Distill BERT, but you can really choose whatever you want. Yeah, and as I said, like you can control these, how the tokens are made very specifically. So for example, linguist here is actually 2 tokens, with linguist is the stem form, and then it has S, which is a separate token. Right, and so I think this is going to give researchers a lot of flexibility. Also before, the spaces were actually sensitive, like you could highlight them, and it would predict the next word, but in this case, spaces are not part of the model. Right, and so, I mean, I want researchers and engineers in the industry, and also in academia, to really use these kind of ways to explain models that I just demonstrated, but also really be hyper aware of this confirmation bias. Because like without that, and you have seen all these papers that have been published, maybe I should have shown like all of them. That's a lot. It is really embarrassing, like how bad we, even as like really careful researchers, are at this. And so you always need to transform whatever intuition you make into a quantifiable hypothesis. Yeah, so I want to end up with the links here. So the slides are available here. This is actually just a browser in Chrome. And then the Python module I wrote here. And we can also go back and look at the other slides. But I'll leave up to Terry and Jispanjan.
Okay, this is wonderful. I think you summarized it very well. The depths obviously intrigue us, and we definitely want to keep good time to sort of educate people. I was looking at the questions. I realized some people are not familiar with RNN, so we were struggling with what is LST and what is GRU. So we'll answer that question as well. If it's no problem, if you don't worry, if you haven't ever sort of played with the deep learning models like GRU and all these other sort of little families of RNN. I think it's really fascinating. There are a few questions, but maybe to give Dipanjan also an introduction. Before we do that, actually, Andreas, I think a question which might be good for people to also know is, that is one thing that you have your intuition, okay? So you take your intuition, you want to kind of solve this problem, you look at what the other researchers are doing. A lot of people are into some rabbit hole and they keep digging. And it's great because the reviewers will approve it because the rabbit hole is full of all Google or Facebook researchers. No offense. So the party is very great, but the question is it intuitive enough? Is it really a research which people would love? So that's one part. The other part people also like to know in research community, but also engineering community, is if I have done a wonderful research, how can I publish it on Distill? So Distill Pub, as you know, was I think Chris Ola, he maintains it together with a bunch of other guys. So can you maybe explain the process of how did you sort of go ahead and sort of expand your research? Your research got a lot of visibility. Also Distill Pub. How did you go and what was the process when you went to publish it on Distill?
Right. I mean, there's not that much to it. Like there's a submit button here, right? And then you submit it. They have like a template you need to use, and then write this, and then really you submit it like you would to any other journal. It's essentially like an email, and then the committee there is gonna like look at it. And actually, I was rejected twice from Distill. It's a really hard journal to get published in. And each time they gave me some feedback, and then like I spent some months trying to improve that. And then I submitted again, was rejected again, and then the third time they then said, okay, this is actually pretty good. And they did also encourage me in the start. They said like this was one of the best visualizations I'd seen, but other parts of the paper were not that great. And then I guess with any other journal really, or conference for that matter, like then you go through the peer review, you get free anonymous peer reviewers. Although for this they can actually choose to disclose what their name is. And then you get a DOI number, which is what all the papers get. This is how you know it's real.
Yeah. Perfect. Wonderful. So obviously it's a tedious process. It's a long process. And the key is to continue to kind of keep sort of going strong with your research. Maybe now I think I'm sure Dipanjan has questions for you. I would like him to sort of spend some time talking to you. I don't know, Dipanjan, I'm sure you collected some thoughts in your head.
Sure.
So please go ahead. So obviously we want to get to know you, audience. I think a lot of folks know you already from our sort of Indian subcontinent. You've presented on several occasions on NLP workshops across India, the whole, I guess even outside India. So maybe a quick introduction and then a Q&A with Andreas before we jump into answering a few questions here.
Sure. So yeah, I won't take too much time, so we can dive into the questions. But yep, I mean, I work as a data science lead. I've published several books in NLP, transfer learning, and I definitely love working with some of the newer aspects of deep transfer learning, especially transformers. And I actually know this library. So when I saw Andreas's name, I was like, okay, Terry is inviting me, and this is like a great opportunity to deep dive into this area and even ask a few questions. And yeah, besides that, I'm also a Google developer expert in machine learning, and I love sharing my work in the form of conferences, articles, papers, and so on. So I guess I'll dive right into the question. So Andreas, I think this is a great library, and I think I've even like used it firsthand. I just wanted to ask some aspects like, let's say like you showed with regard to the transformers, where one of the aspects is like the masked language modeling, where we are trying to find out, okay, what is going to be the word which is masked based on the other words. So my question is, let's say in the industry, if we want to use some of these models where we are fine-tuning them and using it for classification, or let's say question answering, someone wants to build a chatbot. So often what happens is people want to understand, okay, how is this model working? How is BERT really giving you these predictions? So do you think that is something which would be possible, or what do you think would be the next steps towards going or getting there?
Yeah, I mean, like if you have, for example, like a Q&A model, right, which is quite common with BERT, like for sure, I think the visualization might work out a bit differently, but but still, I mean, each word you predict, right, they're gonna have some context. So you could actually just have like the cue in the beginning and the question in the beginning and the answer in the end, and then of course there'll be no like highlights for the question itself, but for the answer there would be. Right. So you could do that in this module for sure. But of course, you can also create more specific visualizations. I think, like in terms of the mathematics, it works out pretty much the same. You calculate again these gradients.
Absolutely. Yeah, because I mean, I was just thinking, like, you've built this library, so like, do you have any plans of adding in more features, or where do you see, like, do you want to take this to the next level with regard to adding more components, or any thoughts on that?
I do want to like work more on creating these kind of visualization tools. I think this one is pretty good as is. Like, for example, the terms here at the top are optional, right? You can disable those. You can only have like one model. And so I'm pretty happy with this as it is now. But yeah, I definitely want to like create more modules in the future for doing this kind of thing. Yeah, for example, like translation models, I think might not fit completely into this.
Might not?
It might not, yeah, because like you really have like two different inputs, right? Yeah.
Definitely. Yeah, I mean, those additions I think would be really great to the community, because I guess, I mean, wherever, even if I'm giving some session on BERT, one of the questions is, how do you explain this to your boss? So I guess that is something which is definitely, I guess the whole interpretability aspect is becoming more and more important. So yep, I think this is good to know. Another question I think which we are seeing frequently, even in the chat, is with regard to the whole families of recurrent neural networks, LSTMs, GRUs. Now, I know for a fact that I've used these models, and in many cases, I've seen that obviously GRUs are faster, and in many cases, they do give a better performance. But is there any kind of conclusion? I know, again, I mean, I'm pretty sure I know the answer here, but do we have any kind of recommendations here as to which models work best, or in what scenarios I might choose one over the other?
No, I mean, I don't think so. Like, I think this is really a part where we don't really understand it, and actually wish more research would be done into it. But also, I think like we actually have theorems in machine learning, such as the no free lunch theorem, right?
Free lunch, yeah.
Which is literally mathematics that says that there will never be like a case where one model is always better than the other.
Yep, I guess that answers that question.
Cool. Wonderful. Thank you, Dipanjan. This is great. I'll just kind of quickly jump into a few questions. Maybe ask Andreas if you can answer this question. You can see it on the
what
screen.
Is the difference between RNN, LSTM, and GRU? Yeah.
Feedback.
So actually, so for the Distill, you actually do need to like give sort of a very general explanation of these things to get published. Like a lot of papers say sort of, well, you need to have read these 20 papers before to understand anything, but they don't actually say it. But Distill really wants like not just to visualize things, but to explain things well, right? Right, and so RNNs is sort of like a common term for this strategy where you take an input and then you carry this thing called a state on, as well as the input itself, and then you get a final output here. And then as you go on, one common issue is it sort of loses its memory of what was in the beginning, because there's been more and more steps in between. And so LSTM and GRU are really just two different approaches to solving that, by having some kind of memory, they call it. Yeah. And I don't think we'll go into the specific mathematics here, but really they try and like solve this kind of fading problem, which is called a vanishing gradient problem.
Yeah. And the exploding gradients as well. So basically,
Yeah.
the whole idea is you have those 4 quadrants, Paritosh and other guys, and I think you definitely have, you ignored the negative quadrant, and that's on the vanishing gradient side. You could use all kinds of, you have, for example, gated recurrent unit. You create all kinds of gates to try to sort of, hold on to the memory, because on long term, it's very difficult to keep to retain the memory on the temporal on temporal basis. So it becomes difficult to kind of retain that information, specifically when it's textual. So all these tricks like GRU and RNN kind of, give you a bit of a more like a sort of, way to retain that memory with input gates and forget gates and those kind of things. Cool. Let me just try to see if there is, yeah, maybe this is also for you. Or maybe let me ask, Dipanjan, do you want to take a shot at this?
Yeah, text today could be very biased. I mean, obviously, no surprises there. We saw what happened with Microsoft's bot, which they had deployed, and because of all the negative feedback within a day or two, it started posting racist comments. And we have seen bias also occurring with regard to translation systems, the gender issues, and so on. So, yep, I think it definitely is true. Now, the thing is, how do we combat this? I guess tools like this is what we really need, where we can figure out based on the feedback, based on these heat maps and so on, as to if we are making some kind of a prediction, what is driving that prediction. That's the whole aspect of the interpretable machine learning or deep learning. So that is, I guess, one of the best ways to combat it. Any alternate methods so far? I mean, honestly, I don't know. And I guess we are just getting started in this whole journey of explainable AI, but I guess there's a long way to go from here.
Yeah, I do want to say, like, confirmation bias in my talk here has not been about models or data. It has been about really psychology of our own minds, which is also an issue. But of course, I mean, there's also lots of other bias issues, right? I think Wikipedia has like a list of 100 different bias issues you can have.
Right.
Absolutely. Absolutely. How about this? You want to take this, Andreas?
How does the future for explainability and interpretability in NLP look like? Do you expect a surge of interest from big players like Amazon and Google? I think like Google is really one of the front runners of this. So they have what they call the PAIR group, people-centric AI research. And they are actually the ones who have published some of the papers I showed here, for example, the benchmark papers, I think. So I actually think like they're doing a reasonably good job. And actually, I wish there would be more research around this in academia. I think actually the industry is leading this right now.
Cool. Thank you. Let me just see if maybe Dipanjan, last question. And we are coming. We have another 4 minutes, and then we can shut down.
Sure. Yeah, I think we have seen LSTMs being used in time series predictions. Again, Andreas, maybe you can take this aspect as to if we are doing some kind of a forecasting model or whatever, be it a temporal data, can we leverage this kind of a framework to explain these models based on time series forecasting, something like that? Like basically a way to explain this. Can we leverage a similar logic or yeah.
I mean, why not? You probably had to like maybe create some different visualization, right? Because you're no longer visualizing characters. Right. So this exact visualization wouldn't work, but you still have time steps, right? And so you still have, you can still calculate gradients with respect to the input, for example. That'll work fine.
Maybe we can get like specific time slices which are really leading to the model making that specific prediction and so on. So yeah.
Yeah.
Wonderful. I guess maybe we can come to a close, and then me and the speakers can have a little bit outside the broadcast studio, a bit of a chat. I think the final sort of, first of all, great, wonderful. I think, Andreas, I'm really excited to have you on this talk. It was a wonderful workshop. I'm sure these links, guys, is all available. It's not like, all the presentations, his paper, and you can reach out to Andreas, whether on Twitter. I'm not sure if you use LinkedIn, but in any case, you have Andreas's email address, and you can tweet, and you can connect with Andreas. I think what I wanted to also say is one aspect which I'm lately following, and I don't know if it's interests you guys as well, including the audience, is the hardware sort of innovation that is happening. Just yesterday, this UK company that has actually come up with a new model called, I don't know, they call it Colossus Intelligent Processing Units. The company's name is GraphCore. They were already sort of coming up with supercomputer that are exceeding the capacity in terms of computation capability that companies like NVIDIA have had. And on the other side, then I'm looking at, sure enough, there is one way to go and start going to that first trillion sort of parameter search. Right now, I think it's a few 100 billion, the last GPT did. So is that the way to go? Or are there better? So on hardware side, definitely there has to be innovation. You cannot expect that your investments keep going because you're going on that hundreds of billions or maybe trillions of parameter search, because that would be a very wrong way to kind of, not only ecologically, but also I think intellectually, it sort of doesn't fit into the idea of how human brain is constructed and how we reason. So I think it's going to be really interesting times. GraphCore, a company called Cerebras, also has a pretty big sort of, they came up with a big sort of wafer architecture. And they are all coming up with these huge supercomputers that are 10 times cheaper than what NVIDIA announced in terms of compute capacity to do BERT and even all these other new models. So hopefully someday, I'm just hoping that all these huge computational capabilities is available to researchers like yourself and to us as well, because right now we are also having this challenge of, well, should I invest $1 million to get a sort of a nice computer cage with 5 of those 800 boxes from NVIDIA, or should I go with another player that for 500,000 euros can give me computation capacity and muscle power, which only OpenAI and other guys have enjoyed so far. So I'm really sort of excited about this future. I know that there's a lot of work that needs to be done, but for now I think this is wonderful. Andreas, I'd love to see you actually sort of take this work. No need to push it unnecessarily. If you're really happy with what you've delivered, you don't have to continue to sort of create iterations, because you shouldn't fall into that researcher trap, which I always say to our researchers. Don't fall into the trap of just doing a repeat just because you have to be in that ICLR or CVPR conference. It's about creating something that really means and can make some really interesting impact in healthcare or in any other field in the industry. And hopefully, someday we will have NLP also succeeding in some way, like computer vision has done in the last couple of years. So wonderful. Thank you so much. I will sort of still leave you with your last thoughts, what you have to say to the audience. Maybe just 1 or 2 sentences, starting with Andreas and then with ending with Dipanjan. Last thoughts, because I see questions keep coming, but we'll answer these questions maybe later, guys.
Hello. Well, I mean, I don't have much to say. Just I think I talked enough. Just thanks for watching. If you want to reach out to me, all my contacts is on andreasmadsen.github.io, LinkedIn, Twitter, whatever, email. And,
wonderful.
Yeah, you don't need to hesitate so much. I get a lot of emails.
Great, wonderful. Dipanjan, last thoughts.
Yeah, I think it was a really informative session. So Terry, first of all, thanks for inviting. And I think the audience definitely made it interesting. I guess we have definitely a lot more to see with interpretable machine learning, deep learning, as well as all the whole aspects of deep transfer learning. So looking forward to even seeing good things in the future. Yep.
Awesome. Thank you once again, guys. And we're going to go offline. We'll end the broadcast. You two, if you guys can just stay on, we'll have a just quick sort of chat before we sign
Sure.
off. Thanks, everybody. Bye-bye.
Thanks
Bye.
a lot, everyone.
Have fun.
Have fun. Take care. Have a good weekend.